So most of the crystals are small, but there is one fairly large one, as you can see here. So my guess of what might environmentally be helping the crystals to grow is I placed them by the window a little bit ago, which I think has helped evaporation happen because it has a little bit more sunlight, so probably encourages more evaporation of the liquid of the water around the alum, which allows the crystals to form. Okay, so to get from 1 gram of aluminum all the way to the alum to figure out what the theoretical yield is, you have to go step by step through the equation. So the first equation went from the solid aluminum to the potassium aluminum hydroxide. So that's what I'm doing here to convert to that, and you use that value of how many grams of that is present to go from the potassium aluminum hydroxide to just the aluminum hydroxide that happens after they get combined. So, and then from there you get that value of grams of aluminum hydroxide, which then you can go from grams of aluminum hydroxide to aluminum sulfate grams, which you get here, which brings you to the last step of going from grams of aluminum sulfate to, using the mole ratio, to grams of alum. So then from here, to find the percent yield, you take the actual yield, which for us was 27.12 grams, divided by the theoretical yield, so like how much it should have made, and multiplied by 100. So I had 154.31%, and the reason that I had more in this case than was expected is most likely due to the vacuum filtration and not letting it filter for long enough, so there's more moisture in the mixture than there should have been. So instead of it being 100% just the alum in there, it was actually some moisture as well that should have been filtered out through the vacuum filtration. It's also possible that there were still some impurities left in it from the original aluminum that has some of that dye and other things in it, but most likely it was from the moisture still being in the alum.